In this video, we will see how to find partial derivatives of higher order for a function z equals fx comma y, where z is a function of two independent variables x and y. We have seen how to find partial z by partial x and partial z by partial y by using definition of partial differentiation. Now this is first order partial derivative. To find partial differentials of higher order, we again differentiate partial z by partial x with respect to x if it exists and write dou to z upon dou x square. Similarly, we write dou by dou y of dou z by dou x again if it exists and write it as dou to z upon dou y dou x, etc. Let us see more about this. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Dou to z upon dou x square is also written as fxx, and this dou to z upon dou y dou x is also written as fyx. Similarly, dou by dou y of dou z by dou y will be dou to z upon dou y square, which is also fyy. Dou by dou y of dou z by dou x will be dou to z upon dou y dou x, or simply fyx. Further, dou by dou x of dou z by dou y will be dou to z upon dou x dou y, or simply fxy. If z equals log x square plus y square, we will find dou to z upon dou x dou y and dou to z upon dou y dou x. First, dou z upon dou x will be dou by dou x of log x square plus y square, which is 1 upon x square plus y square dou by dou x of x square plus y square according to the chain rule, which is dou by dou x of x square plus y square will be 2x upon this x square plus y square. So dou z by dou x will be 2x upon x square plus y square. Next we find dou z by dou y, which is dou by dou y of log x square plus y square. That will be 1 upon x square plus y square into dou by dou y of x square plus y square, which will be dou by dou y of x square plus y square will be 2y upon this x square plus y square. Now from this first order partial derivative dou z by dou x, we find dou by dou y of dou z by dou x, which is dou by dou y of this 2x upon x square plus y square, which will be this 2x, which is to be treated as constant because we have to partially differentiate with respect to y, into dou by dou y of 1 upon x square plus y square. This will be 2x into, now dou by dou y of 1 upon x square plus y square will be minus 1 upon x square plus y square into derivative of y square 2y. So here we get dou to z upon dou y dou x as this minus 2x into 2y 4xy upon this x square plus y square. Let us name this 1. Next, from this dou z by dou y, which is 2y upon x square plus y square, a first order partial differential, we will find dou by dou x of this dou z by dou y, which will be dou by dou x of this 2y upon x square plus y square, which will be, now since this is to be partially differentiated with respect to x, we have to treat this 2y to be constant, so this will be 2y into dou by dou x of 1 upon x square plus y square, which is 2y into. Now dou by dou x of 1 upon x square plus y square will be minus 1 upon x square plus y square into derivative of this x square 2x. So this dou to z upon dou x dou y will be minus 2y into 2x 4xy upon x square plus y square. We name this 2. Here we observe that in 1 and 2 the right hand side is same, so we can equate their left hand sides. So what we get finally is dou 2z upon dou x dou y equals dou 2z upon dou y dou x. But this need not be equal always. If u equals x cube y plus xy cube, find partial 2u upon partial x square and partial 2u upon partial y square. First, let us find dou u by dou x, which is, for this x cube y, we have to use product rule, which will be x cube into dou by dou x of y plus y into dou by dou x of x cube plus, for x y cube we again have to use product rule, that will be x into dou by dou x of y cube plus y cube into dou by dou x of x, which is x cube into 0, because we have to differentiate with respect to x, so y will be constant, plus y dou by dou x of x cube will be 3x square plus x into dou by dou x of y cube will be 0, because y cube is constant, plus y cube into dou by dou x of x will be 1. So finally dou u by dou x will be 3x square y plus y cube. Next we will find dou by dou x of dou u by dou x, which is 3 into, we will use product rule for x square y. So first function x square, partial derivative of y with respect to x will be 0 plus this y into partial derivative of x square with respect to x will be 2x plus partial derivative of y cube with respect to x will be 0. So dabba square u upon dabba x square will be 6xy. Now we have to find dou u by dou y, that will be dou by dou y of x cube y plus xy cube, that will be, for x cube y we have to use product rule, so x cube into dou by dou y of y will be 1 plus y into dou by dou y of x cube will be 0, because it is partial differentiation with respect to y, so x to be treated as constant, plus now we will partially differentiate x y cube. So again using product rule, x into dou by dou y of y cube will be 3y square plus y cube into dou by dou y of x will be 0 again. So dou u by dou y will be x cube plus 3xy square. Next we have to find dou 2y upon dou y square. So dou by dou y of dou u upon dou y will be dou upon dou y of this x cube plus 3xy square, which is dou by dou y of x cube will be 0, because x is to be treated as constant, plus 3, and again we have to use product rule for xy square, so that will be x into dou by dou y of y square will be 2y plus y square into dou by dou y of this x will be 0 again. So finally we get from this dou 2u upon dou y square equals 3 2s are 6xy. Now since the right hand side in both these equations is same 6xy, therefore we can write dou 2u upon dou x square equals dou 2u upon dou y square. This generally happens when the functions are symmetrical like this. If u equals e raised to ax sin by, we have to prove that dou 2u upon dou x dou y equals dou 2u upon dou y dou x. First we find dou u by dou x, that will be dou by dou x of e raised to ax sin by. We will use product rule on this, which will be first function e raised to ax into dou by dou x of sin by, that will be cos by into dou by dou x of by, plus second function sin by into dou by dou x of e raised to ax, that will be e raised to ax into cos by into dou by dou x of by will be 0 because we are differentiating with respect to x. So y is to be treated as constant plus sin by into dou by dou x of e raised to ax will be e raised to ax into dou by dou x of ax will be a. So dou u by dou x will be a e raised to ax sin by. Next we find dou by dou y of dou u by dou x, that will be dou by dou y of a e raised to ax sin by, that will be a into, we will use product rule for e raised to ax sin by, so that will be e raised to ax dou by dou y of sin by will be cos by into dou by dou y of by will be b plus sin by into dou by dou y of e raised to ax will be e raised to ax into dou by dou y of a raised to x, that will be 0, which will be ab e raised to ax cos by, and this is dou to u upon dou y dou x. We name this 1. Next we find dou u by dou y, which will be dou by dou y of e raised to ax sin by, which is again using product rule for this first function e raised to ax into partial derivative of sin by with respect to y will be cos by into partial derivative of by with respect to y will be b plus second function sin by into partial derivative of e raised to ax with respect to y will be 0 because it is a function of x. So dou u by dou y is b e raised to ax cos by. Next we have to find dou by dou x of dou u by dou y, which is dou by dou x of b e raised to ax cos by. This will be b into partial derivative of e raised to ax cos by. So first function e raised to ax into partial derivative of cos by with respect to x will be 0 because it is a function of y plus second function cos by into partial derivative of e raised to ax will be e raised to ax into partial derivative of ax with respect to x will be a. So from this we get dabba to u upon dabba x dabba y equals this ab into e raised to ax into cos by. We name this 2. We observe that the right hand side of equation 1 and equation 2 is same, which proves that dabba to u upon dabba x dabba y is equal to dabba to u upon dabba y dabba x. If u equals tan inverse y upon x, we have to prove that dabba to u upon dabba x square plus dabba to u upon dabba y square equals 0. First, we will find dabba u by dabba x, that will be dou by dou x of tan inverse of y upon x, which is 1 upon 1 plus y square upon x square into dou by dou x of y upon x according to the chain rule, which is 1 upon x square plus y square upon x square into dou by dou x of y upon x will be constant y and derivative of 1 upon x will be minus 1 upon x square. So dou u by dou x will be x square upon x square plus y square multiplied by minus y upon x square, cancelling this x square minus y upon x square plus y square. Now we find dou by dou x of this dou u by dou x, that will be dou by dou x of minus y upon x square plus y square. This will be constant y into dou by dou x of 1 upon x square plus y square will be minus 1 upon x square plus y square whole square into dou by dou x of x square plus y square, which is y upon x square plus y square whole square into dou by dou x of x square plus y square will be 2x, that we write as 2yx. So this is dou 2u upon dou x square. We write it here. Dou 2u upon dou x square is 2xy upon x square plus y square whole square. We name this 1. Now let us find first dou by u by dou by y, which is 1 upon 1 plus y square upon x square into dou by dou y of y upon x, which is 1 upon x square plus y square upon x square into dou by dou y of y upon x will be constant 1 upon x multiplied by derivative of y with respect to y 1, which is x square upon x square plus y square into 1 upon x. X cancels with 1x of x square and we get dou u by dou y equals x upon x square plus y square. Next we find dou by dou y of dou u by dou y, which is dou by dou y of x upon x square plus y square, which is constant x into dou by dou y of 1 upon x square plus y square will be minus 1 upon x square plus y square whole square into dou by dou y of x square plus y square, which is minus x upon x square plus y square whole square into dou by dou y of x square plus y square will be 2y. So dou 2u upon dou y square will be minus 2xy upon x square plus y square whole square. We name this 2. Now if we add equation 1 and equation 2, it will be 2xy upon x square plus y square whole square minus 2xy upon x square plus y square whole square equals 0. Hence, this is proved. If you like this video, please like it, share it, and subscribe to this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.